This video is all about indices and index flows, and on this lecture we would be covering all the basic topics of what indices are, and then we will move on to index flows and its subsidiaries with some examples. So no further ado, we shall start right over. Let's start with an example itself. Let's say I'm having 5 times 5. So here I am multiplying 5 3 times. So instead of writing it as 5 times 5 times 5, I can write it as 5 to the power of 3. So here 5 is what I am multiplying, and 3 represents how many times am I actually multiplying this 5. Let's go for one more example. Let's say I am multiplying 4 times 4. So here I am multiplying 4 how many times? Exactly 2 times. So 4 to the power of 2. So now as a general expression, I can say that if I am multiplying A times A times A times A, let's say I am multiplying it m times. Okay, I am multiplying it m times, then this would be equal to A to the power of m. And in this case, the A is nothing but called as the base, and the em is nothing but called as the index or power. So that's all about the basic things of what indices are. Now apart from going on to the index flows, we would be covering the small subsidiaries of index flows, and then we will move on to the index flows itself. These are the main subsidiaries of index flows. The first one, a to the power of 0 equal to 1, a to the power of 1 equal to a, and the nth root of a equal to a to the power of 1 by n. Now let's consider an example for each of these questions. The first one, a to the power of 0 equal to 1. That means if I'm taking the power as 0, that means let it be any number. Let it be a positive number, let it be a negative number. If I am taking the power as 0, the answer will always be equal to 1. For example, let's say I am taking 4 to the power of 0. That is equal to 1. Another example, negative 1 to the power of 0. That is also equal to 1. So any number to the power of 0 will always be equal to 1. Now second one, a to the power of 1 equal to 1 equal to a. That means any number to the power of 1 will always give me the exact same number itself. Same thing for positive as well as for negative. For example, let's say I'm taking 3 to the power of 1. That is equal to 3 itself. Or negative 2 to the power of 1. That is also equal to negative 2. Now the next one, the nth root of a equal to a to the power of 1 by n. Here we are actually having a small misconception. Let me ask you a question. What is this? Most of us would be saying it as square root. Yes, generally it is considered as square root, but we can say it is nothing but a root only. Okay, and the number that I'm writing here, if it is 2, then it can be considered as a square root, and again generally it is considered as square root itself. And I can have different roots as well. I can go for square or cube root of 3. So here I am finding the cube root. So the number represents which root am I actually taking here. So that means if I'm having a general idea of the root of the nth root of a, then I can write it as a to the power of 1 by n. For example, let's say I need to find out the square root of 6. This I can write it as 6 to the power of 1 by 2. Another example, the fourth root of 5. This can be written as 5 to the power of 1 over 4. I hope this idea is clear. Now we will move on to the index flows itself. And these are my 4 index flows. The first one, a to the power of m times a to the power of n equal to a to the power of m plus n. Second one, m to the power of a times n to the power of a equal to m times n the whole to the power of a. Third one, 1 by a to the power of m is same as a to the power of negative m. Fourth and last one, a to the power of m the whole to the power of n equal to a to the power of m times n. Now we will discuss about each one of these. Let's consider an example for the first one. Let's say I am having an example like this: 3 to the power of 4 times 3 to the power of 7. So here what you have to keep in mind is that I'm having a common base here. So on the answer also, I will be having the exact same base, that is 3. And then what do I have to do? I have to add the powers, that is 4 plus 7. And that will give me the answer as 3 to the power of 11. So always remember, the common term remains the same. Now moving on to the next one. Let's consider an example. Let's say I need to multiply 7 to the power of 4 times 5 to the power of 4. So here, what do I have common? I'm having the common as the power itself. So on the answer also, I will be having the exact same power, that is 4. And then I just have to multiply the 7 and 5. That is 7 times 5. And that will give me the answer as 35 to the power of 4. So here, since the common thing was the power, on the answer also I will be having the exact same power itself. Now moving on to the next example, that is 1 by a to the power of m equal to a to the power of negative m. That means, let's say I'm having 1 divided by 4 squared. Okay. So I need to bring this 4 square to the numerator part, and I can do it by changing the sign of its power as 4 to the power of negative 2. So if I'm bringing a power term from the denominator to the numerator, I just have to change the sign. If it is positive, it becomes negative in this, like this case, and if it was negative, it will become positive. And you can also do the opposite. Let's say I am having 3 square. I can also make this 3 square, or make the 3 square go to the denominator, and I can write it as 1 by 3 to the power of negative 2. I hope this idea is clear. Now moving on to the last one, that is a to the power of m, the whole to the power of n equal to a to the power of m times n. Let's consider an example. Let's say I want to find out 5 to the power of 3, the whole power of 2. So here I just have to multiply the powers, that's all. That will give me 5 to the power of 3 times 2, and that is equal to 5 to the power of 6. And that will be my answer. That's all for today. If you are having any doubt, please comment it below, and please tell me what you would like to see on my next video as well. Till the next time, take care. Bye.